I'm Simon, covered that bit. And we're talking today about domain-driven design and transitional architecture and how we can use those two things together. I'm a big believer that software is always a journey. You learn stuff along the way, it has highs and lows. So I'm going to try and do this in the context of a story with a narrative. And it's going to be the story of moving away from a wicked old system. You don't have to boo, but you can if you want, but do it at the right point. So this is from Kurt Vonnegut, the US author, from his autobiography. And he posited that you can describe most, if not all, stories as data points in a graph. So it's a massive spoiler alert, I'm afraid, because an awful lot of stories, whether it's Hamlet, Legally Blonde, they all tend to follow this sort of pattern. So it can either be happiness, joy, good things, good fortune, ill fortune. You start off, this is the boy meets girl one, so it's fairly neutral, he's doing okay. Towards the start, great things happen to him. Joy of joys, he's met a girl who couldn't imagine being any happier. And then as you get further through the film, it all comes crashing down, they split up, there's a terrible misunderstanding, we're all cringing, but we all know in the back of our minds it's going to shoot up again and they're going to get back together. Whew, glad that's all clarified. And he's actually at least as happy as he was at the high point, maybe happier. Similar one over here. This will get back to software at some point, but do let me know if it gets dangerously close to the football. Over on the right, we've got Cinderella. Cinder starts off from a much lower point. Things aren't great when she starts off sort of quite down on that fortune graph. There's some weird stuff going on with a fairy godmother. Nobody really knows much about that. And then Joy of Joys, she meets a handsome prince. All comes crashing down pretty suddenly. Cinder's has got ill fortune again. She's not quite as bad as she was at the start. Slipper fits, and then she's infinitely happy forevermore. Brilliant. What's the relevance of all of that? Well, I wonder what the story would look like when we typically move away from a legacy system. Perhaps it looks a bit like this. So we maybe start off in a terrible place, and we know we need to move away from it. We get some buy-in to do that. We start. Takes a while to get going. That's the sort of first dip here because we're busy doing new things, and then there's problems with the existing system, and we pulled some of the best people away from that to help us with the new system. We think we get something that's pretty good, we get it out there, we realise we've misunderstood the problem, got to roll it back, more bugs have come in, and it's a pretty difficult project. And I should probably have stretched it because it just goes on and on and on. And if you're lucky, you might end up marginally better than you were when you started from. I might just pause there and say, you don't have to sort of incriminate yourselves, but has anybody here either working currently with some system that's pretty old, legacy, they want to move on to a newer version, or done so in the past? Anyone recognise this graph? Sorry?
It's not normally that positive.
No, that I get a little bit optimistic, a bit carried away myself. I should have said as well, I should have mentioned, if I come back one, hopefully, back the other way. There we go. This, I think, is also the graph of England v Switzerland, I realised. First half and second half of the penalty shootout, so we'll see how we go later and we can graph that. So I thought I'd spend a bit of time before we talk about the Wicked Witch and the legacy system we're trying to get away from, just covering how we like to build software. And these are some patterns that we use currently, we find to be quite useful, and they have a bearing later when we start to think about how we can move away from complex legacy systems. So we make pretty heavy use of domain-driven design. Rob Allen did a great talk a few months back. I won't sort of go over that again, I couldn't if I wanted to. But just some of the high-level points there. We've got a sales context here and a support context. So the idea is, when it comes to modelling and designing the system, we don't need to model everything and be consistent, with the whole universe. That's impossible. So just your product, your department, that's your bounded context, that's the product, that's where you need to be consistent. So if words mean different things in different contexts, if what I mean by a service in the sales system is different from a service or a ticket in the support system, that's fine. We're not going to kill ourselves trying to argue over what we call things. But as far as our own context is concerned, our own product, the people we work with, is really, really important. So we have one glossary, one set of terms. That's reflected in what the users see. It's reflected in how we build the software, the names that we use for classes, and naming is hard. I definitely agree with that. So we're really influenced by that. Try to come up with consistent namings, but only as far as our product goes and what works for us, the problem we're solving. And we find that that's really great as a collaborative exercise. There's lots of different ways you can do that with sort of event mapping and big sort of exercises. We just work really closely day in, day out with our head of product. We all talk the same language. I'm just going to call out a little bit these root objects. So you can imagine something comprised of many, many parts. But if you go to the top of the tree, I've got a good slide on that next, I think, then that's really key for us. We're not able to model every single detail here. So a salesperson has got arms and legs and a desk and whatever else, but we're just mapping that top of the tree salesperson. And in particular, we think about the data, how data changes, the data related to a salesperson or a pipeline or an opportunity, how that changes and what its life cycle is. The reason we do that, it's the same as any software challenge or project. We're trying to just put things in the right boxes. If it's a desk and we've just got papers all over the desk, it works for a bit and then we can't find our way around it. If we put things in the wrong drawers in the desk, we're not really helping anybody, or stuff it all into one drawer, that's not a lot better. So it's all about organising it to make it easier for our future selves when we come to maintain and extend it. If only there was a diagram gave an example of one of these aggregates. Oh, look at that. Well, it's not a diagram, it's a picture. So I like the analogy of a car. So a car is made up of many parts. You don't book your steering wheel into a garage, you book your car into the garage. So those are the conversations we want to have. So a car there is an aggregate, it's top of the tree. The garage probably is as well. Somebody working there is, a calendar might be. These are the top of the tree entities, and we think about the interactions. So what we work particularly hard to do is to try to think, what is the data that sits within an aggregate? What's the data that sits within a car? What are the parts? And why do they change? So for example, if you need to repair something on your car, you need to replace it, the repair and the replace operations would sit probably within that car. Maybe you drive a car, that's a function of the car. Maybe repairing it is actually a function of the garage instead, but it's all about thinking about, with these operations, which data do they touch and update, and trying to put the operations as close to the data as possible. And in particular, we'll cover this a bit more, but our approach is less about having a whole load of getters and setters, which a lot of frameworks encourage you to have. You can very easily end up with getters and setters, the anemic domain model as it's called, and then a whole load of services which are very procedural. So you can imagine having a whole load of entities for all different parts of a car, the mechanic, the calendar, where you check your car into, loads and loads of entities and a whole bunch of services that are very, very big and manipulate entities from all over the place. The fundamental thing that we do is try to think, what are the aggregates, what are the top of the tree entities in the domain, what's the behaviour that should sit with them, and then we actually put as much of that behaviour as we can into the entities and the aggregates themselves. So we try to keep the services quite lightweight and the logic sits within the entities themselves. So this is an example from the current domain where I work now. We work with employee benefits, digital benefits, pensions, private medical insurance, cycle to work schemes, making that available to small businesses. So for us, the aggregates that we deal with are employees, the benefits themselves, where that might be a pension benefit, the rates, how much it costs, who's eligible for it. And a big part of what we do is whenever the employees change or the benefits change, we need to keep a really up-to-date data set of who is eligible for those benefits. And then people have benefits and they have a certain amount they pay for it every month. So we need to make sure that their costs are up to date. And it's very, very easy to start crossing the streams with this, but we use DDD to help tease out what are those top-level aggregates and what's the behaviour that they're going to have. So if we're going to calculate costs, it would be very easy to say, there's about 4 ways you can do it and all up there. But you can say a person has a benefit, so just against an employee service, calculate their costs, all the logic's in there. You could have a benefit with a lookup table, you could tell the benefit to do it, or you could move it a lot closer to the selection itself. So an employee has chosen a benefit, they've got a particular salary, and based on that, we need to calculate the cost. So it's all about where that sits and what data we're going to manipulate there. I won't show you the entire code base, but hopefully it gives you a bit of a feel for just thinking about why data changes, which data goes together, calling things by consistent names and trying to put them in the right boxes. And these are just some day-to-day practices, These are the day-to-day practices that we find work for us, and people have variations of these. At a sort of high level, the aggregates we looked at there, they inform the RESTful services that we've got, the different modules, Docker containers, things like that. day to day, we really sort of try to let that design emerge. It's really hard to sort of think of it all up front. That's not how software works. So we're big believers in, I mean, they're probably not even called XP practices. They were 20 years ago when I discovered them. I think some of them we just do it. It's just how we work now. We like to work in small releases, have automated testing. But this inner ring here is particularly relevant for us. So when we've got some functionality we want to build, we will write a very small test for that. It will be red-green, and it will last, probably take about 20, 30 seconds to write that test. We'll do just enough for one scenario, we'll run it, it will fail. Of course it'll fail because we haven't written any code yet. We'll write just enough to make that test pass. We'll run the test again. This is all about 2 minutes later on now. It passes, it's green. And then we pause before we add the next test in and go around the loop again. We pause and say, right, we know it works. Is there anything we can clean up? And in particular, is there any duplication? So that's with the refactoring mercilessly. We clean up any duplication, whether that's putting it into small private methods, or when we get enough of it, we start to split it out into separate classes, and then we start to think, hang on a minute, there's data here that's changing at the same time, maybe we need to tease out an aggregate from it. So very emergent, very iterative, but those patterns work really well for us. We keep design simple, we pair to try and discuss things the whole time. We use DDD and refactor mercilessly. So this is our happy place. Just see if I can work out which the up and down keys are. We try to put things into the right boxes. We think in particular about top level entities or aggregates. Try to put the behaviour close to them. We check our car into the garage, not the steering wheel. So when those aggregates are interacting with each other, they're calling top level services and functions rather than messing around with each other's data. And then in particular, we try not to have too many CRUD operations. We try to have business operations. So maybe just a simple example to bring this to life a bit from a different domain. Worked in sort of billing previously with the utilities where we had to generate bills for millions of customers. And there was a renewal journey, and there are a couple of ways you can do that. One way is you can provide access to any service you want from your contracts. So a renewal, after all, is just a case of stopping one contract, deleting it, creating another contract, moving lots of the details across, and that's it. So it'd be tempting to have a contract entity with lots of CRUD operations, knock yourself out with this big service that does that. What we would do here instead is we would introduce a concept of a renewal that has its own life cycle, and then the business operations for a renewal would sit within that, and the renewal would contain all of that logic itself and be inherently consistent. It would make sure it's always in a valid state. I'm going to introduce the Wicked Witch, so watch out everyone. But just before I do that, I might break with the format a little bit and just ask if there are any questions on that first part, which is how we like to build software, how we use DDD. I should keep rolling. Sweet! Okay, work you up. So this is the system that we started moving away from probably about 3 years ago now. So it was a live software as a service product. It was our core product. It's the thing that we do. It's what we license. It's not something peripheral. I think if you've got a system that you don't really care about, then this is very, very difficult. So maybe just don't bother doing it or get someone else to do it. This is our core product. We had tens of thousands of customers using it every day, hundreds of different companies. And we found these problems with it. Anything we wanted to change was really slow and risky. So I think that's always a good sign of whether you've got things in the right boxes and built things in a clean way, is whether changes are proportionate. So if you want to change a bit of text, change a calculation, someone could describe it that simply, it should feel like, yeah, sure, I can go in and make that change and release it quite quickly. We would be sort of frowning and stroking our chins and saying it depends for even those really simple requests. So simple change is slow and risky. We were never quite confident if we change one thing, what might happen elsewhere. It's a bit like a sort of whack-a-mole approach. I suppose you sort of bash one down, something else pops up, and yeah, very, very sort of uneasy feeling there. I think because of that, because of the complexity involved and the number of files that needed to change, the tests that we needed to run, it meant that the releases became quite large. And as we all know, the bigger releases become, the more risky they are, and then the fewer of them you do, and you end up in this downward spiral. We have performance and stability challenges. It's really hard to scale the product and have multiple instances running. There's some real performance bottlenecks where you can see all of the compute power available on the cloud, but the way the application's written and the loops it's going around, it's just not going to make much difference. You can't sort of get in there in order to scale it out horizontally because it's all so entwined. There are old frameworks in there, security worries. To make things even more complicated, we had a user interface that was out of date as well. Where some nasty downstream issues due to data where we hadn't even done anything. Just do nothing, 3 months later, problems on report, somebody's being charged the wrong amount, for example, and that's all because data's coming into the platform, it's not being validated correctly, garbage in, garbage out. I know some quite complicated concepts in there that seemed like a good idea at the time, but they're actually holding us back, constraints in the system, rules that didn't make sense. Hard to monitor, no testing there, and very few people who knew about the system were able to maintain it. And people not super keen to learn about it either, with that list of things I've described there. The question then is, where do you start? And I don't think this is a Dave Allen original, but Dave Allen was Irish and he says it so I can get away with it. I won't do the accent, but the old joke is, tourist is lost and says, excuse me, can you tell me how to get to Dublin? And the local says, oh, if I were you, well, I wouldn't start from here. And that's definitely a feeling we've had where we know how we want to build software. For new things, we follow that approach. It works really, really well. We want to get over here with the legacy system, which is the core part of our business, but it looks like this. How on earth do you feel your way into that? So a few different options. The first one, I definitely recommend if you can get away with it. If it's going to solve all of your problems, do number one. So just make small changes. Resources from people like Kent Beck are great, sort of tidy first approach. Make small, meaningful changes in the problematic areas. And actually, maybe there's an 80-20 rule. Maybe you haven't got a list as long as the one I shared. Maybe you knock down the areas where you've got problems. You keep one system live. You don't have a big migration project that goes all the way across the screen and ends up still below the level. So if you can get away with that, great, but sometimes it won't cut it. Normally I try to say it depends, and it always depends on the context, and not to say thou shalt do this or that. Number two is about the closest I come to saying you shouldn't ever do that, I would say. The idea of just starting again or building a new system is just so appealing when you're in the depths of wrestling with the old code and things are going wrong when you've got all of those problems. Just starting again feels great for a while, but assuming you've got people using that existing system, you still need to maintain it, you need to get them across to it, you end up with a lot of problems I've always found. The main reason being, it's not like a system you're taking off the shelf, you're trying to build the system, so you don't really have any way of being certain that it's working, either in terms of being technically correct and solving the problems that it should, or that it's actually giving customers what they want and need in terms of functionality. So you go on and on and on, building things that you're not really validating until you get to functional parity, which is probably going to take you years because you don't know the system very well, because no one knows what the old system does. There's more and more and more. The two systems diverge and it becomes a sort of never-ending quest to bring them back together again. So wouldn't recommend number two, as you can probably tell. Say what you really think, Simon. Number three, definitely that's quite appealing. I've done that one as well. I've kind of lived through all of these. They've all got their strengths and weaknesses. Number three, I've seen it work quite well with that the utilities and billing that I talked about, where if you can come up with a sort of cohort of existing customers that have a reduced set of functionality, maybe they could go across to the first parts of your new system that you built so far, and then you're getting feedback on the parts that you built so far. You're still servicing all the existing customers. You can start to plan that transition moving across by customer. Challenge I found with that is customers don't stay the same, they don't behave themselves. So you might bring customers across on a fixed contract, for example, for 2 years. At that point, the clock starts ticking as to when you're going to have that renewal service ready. Otherwise, you find that they can't renew because you haven't finished that bit yet. So you're either putting them on with loads of operational support to try and fill in the gaps, or you end up putting them back to the old system because you've hit some limitation. And that's not great if you've got sort of weekly reports to the board about how many customers are coming onto the platform, and the numbers start to go in the other way and they're going back on the old system, and you're hiring more operational staff to cover the gaps that you've got. So that can work, but definitely you need to know your customers, and it's pretty stressful. Number 4, you can have a go at building a new system in stages and integrating with the old as you go, and that is the transitional architecture. So, there's a useful set of patterns from ThoughtWorks that they've documented to help avoid these big bang migrations. So to give you some useful structures, I suppose, and a common language for how you might move parts from the old system into the new. And essentially, what this can allow you to do is to release and validate stages. So all the stuff we saw, seems like a long time ago now, all that DDD stuff and the XP practices and TDD, you can do that on your new components that you're building, but you can also integrate them with your existing system in such a way that you know they're working and there's just one system that's out there at any time. You don't have two systems and a gap that's increasing. It doesn't come for free. Bridging the two systems and trying to make it so you've got an old system with bits of a new system around it, that's complicated as well. And a good way to think about it, I think the way ThoughtWorks describe it, is as scaffolding. You're going to need to put up some scaffolding around the application to be able to do that in a safe way. And we used a variety of those patterns when we were moving away, modernising our core product with the employee benefits. So I'm going to go through 3 of those patterns. There is what I think might be a slightly more favourable graph at the end as well. So coming back to DDD, this is where we found it really valuable. So I learned earlier from Tom that is it hexagon is the bestagon, I think. Nice little video. Yeah, I love it. Yeah. I won't get distracted talking about how hexagons tessellate, although I want to. Don't do it. So these are essentially the aggregates or subdomains that we identified. So you recognise them earlier from the sort of space rocket graphic I had with eligibility and employees. So these top level aggregates, those are the sets of data that are quite independent and the behaviour that we put underneath them. So we had a good debate about where things should sit and which entity is best placed to own the services that go with that aggregate. So benefits, eligibility and so forth. So these look nothing like the legacy systems. The legacy system's all like that. If a legacy system looked like this, we wouldn't need to move away from it. It would be great, it would be really well structured. So that's the challenge we've got. But this is what helps us think about how we want the new system to look, what the relationship should be, how we can model the business in a good way. And then what we do then is we go looking in the old system and we think, okay, what needs to come across in terms of data from the database? We want to get it probably into our new tables and new structure. Which services do we need to move across? Who's accessing those services, whether it's UIs or other systems? And how do we make one system out of that comprises, to start with, just one of these hexagons, and the rest of the system. And it's also called the strangler pattern sometimes, so you gradually strangle all the connections to the old until there's nothing left. There's no references to, say, benefits in the old system, and then ultimately there's nothing left of the old system at all. And you can also do that by priority. You can go in gently with one of the easier ones, or you can go where the pain is and focus on that to try and solve some immediate problems. So 3 different patterns that we used. This one, branching by abstraction, probably seen this, used it in terms of Git branching and not having long-running branches. The idea is essentially we've got a piece of code, let's say for cost calculation I mentioned earlier, that's in the legacy system. It's not got a great structure, it's got loads of bugs, it's really slow. We know what we want that to look like, we know what data it looks like, so we start building this in the new system. But rather than having that in its own branch, we're going to first of all put an interface over the existing code that we have. And I might just break out and cheat and show a diagram from Martin Fowler at this point. There's no point in me waving my hands about when he's done beautiful diagrams. So here, you can imagine in the old system, we've got 3 areas of the client code, and they're calling this flawed supplier. They're calling the code that's causing the problems. And they could be doing that over a RESTful interface, an event, it could be some horrible inline code, it could be any of those combinations. So first thing to do is just to get an interface over the top and to get one of these pieces of client code going through this new interface. It's not doing anything different at that point, and the other 2 are still using the flawed code directly. The reason we do that is we can start to build a new implementation here. So we can start to, well, this one here is just showing all those different pieces of client code going across to that new interface. You don't have to do it that way. You can do it in stages, but ultimately you end up at a point where you build the functionality that's required in the new way. You can test that in parallel, you can have toggles, you can run the two together, and when you're confident, you flip the switch and then you move away from that floor to fire. So for us, we had some algorithms that weren't working well for us for calculating costs. We built new versions of that using TDD and all of our practices, and then coming back here. We had a pluggable strategy where on production, we could toggle whether we wanted the old or the new calculations to be used. And this wasn't easy. It wasn't a case of, oh, we've just got one class here and another one here. They were in different cloud architectures, had to make remote calls, deal with authentication, but that scaffolding was worth it. It meant we could run the two algorithms alongside each other and then cut across them when we're confident. So if it's algorithms and you can find out the points that they're calling it, that's a really nice way of building an adapter to do that. And you haven't got something, you're actually getting feedback on that at the time. You're potentially releasing that code live that's fixing some of the problems that you have rather than fixing it in the old code. So you actually started to make inroads. I felt I had to put a screenshot in of the test just to show that they passed, but I'm sure you would have taken my word for it. So it ain't always that simple, I'm afraid, and that wasn't particularly simple. The next part is to add the idea of a repository. So if it's just, I say just, but if it's only algorithms and calculations, that you can often solve that with the branch by abstraction and adapters. The harder part, in this case, it's always around the data. So what we found was we had the new code that we're calling, that was working out how much people's benefit costs, so how much we needed to deduct each month for a pension, let's say. After that, it was saving it in the database along with a whole load of other data, and loads of parts of a legacy system were going straight to those database tables to get what they needed. They weren't going by an interface at all. So with our new code that was very clean, we had a slightly different model, much cleaner. We'd like to put it in our own tables. We'd like everybody to go via the interface to get that data. That would have been like pulling at a thread, and that's where the problems can come with legacy systems. You start off thinking you're just replacing the algorithms, but now you're replacing, in that first iteration, but now you're actually replacing how the data's stored, and now you're also replacing all the client bits of code that are retrieving that data, and before you know it, I can't release that small fix to the pension logic because I'm rebuilding the reporting system. So this is where those seams and those boundaries become really important. So to avoid pulling at a thread, as I've called it there, we slotted in repositories. So we've got the new code here. Beam is our new system, so it's going through that new strategy, the new code, nice and clean, new models. When it comes to saving it, this is one of the DDD tactical patterns that Rob mentioned. We just throw it out to a repository, and at that point, what the repository is doing behind the scenes is mapping it to all sorts of unpleasant tables and putting it back into the old data structure. That means we get the algorithms out there, we get them working, the rest of the system works. We go down the path, we start again the next week, and we think, right, what do we do about those tables? But everything's not all connected, we're actually making inroads. Third one's really nasty. So, third one is where the volume or the amount of data you're changing is so complicated you can't get away with just slotting in a repository. So this example here talks about sales system and business performance system and logistics system. So the idea is the logistics system, that's a whole new part of code, whole new service, whole new aggregates there, whole new use cases that's supporting. And inside the logistics system, there'll be new services, new models, rich models, and new database tables to hold that. And that data needs to be there because the logistics system is going to be quite complex. It needs to maintain that state, so it can't just not put it in the database. Unfortunately, it's not just a table, it's entire systems, so business performance and sales that are going straight to that legacy system, and they're expecting not just one table, they're expecting whole sort of graphs of tables to be populated, complex data there. So in that case, the repository is not really going to get you there because you're going to have a model that's so different from what you've got. in the database. It's probably going across aggregates and boundaries and all sorts. It's going to be pretty difficult just to try and write that back in code. So here the legacy mimic comes in. This is sort of scaffolding I was talking about, where periodically the new system, it also needs to sync back all of that related data back into the legacy system in order to support those other operations. So you've essentially got two versions of the truth, two copies of the data, something which I would say never do again. But that is kind of the only way you can get your new logistics system in there and get it working. You could almost putting a boundary around it as though it's a third-party system and you're building an adapter to push data into the other parts of the system. And that allows you to get the new logistics system out there and then come after business performance and sales separately. So a lot of it's all around putting boundaries around things, going in stages, keeping the lights on in the existing system and resisting the urge to say, well, since I'm doing that bit, why don't I just do that bit as well? And then, because that's how it starts, and instead of days and weeks, you get into months and years of not releasing. Going the other way, just for completeness, that's the event interceptor. So there may be areas, parts of the code in sales and business performance that are also generating new data for logistics. So having a way to intercept that, listen on that queue and say, oh, I'll take that, thank you very much, and route that into your new logistics system is really important as well. So maybe not rewriting significant parts of sales and business performance, but just picking out when they are creating new logistics entries and taking it into your new code. So it can eventually look something like this. This is sort of intended to show the journey that we went on, where pretty flat to start with while we're building all that scaffolding and thinking, oh my goodness, how are we going to approach this? Start to get inroads, make some inroads, get some progress with the services we've carved out there. And then inevitably, because the legacy system isn't self-documenting, it's hard to know what all the use cases and nuances are. You make mistakes, so you need to back things out and then you go again and put things live. And it's really a kind of pattern that you kind of get a feel for it over time. You get to get a feel for which things you can do just with branching by abstraction, which is great. Repository, that's fairly manageable as well, and where occasionally you've got those legacy mimics and you get a bit better handle on that. And eventually you start to move enough of the system across that it becomes more predictable, and the defects that you might have in the old system are gone, or if they're still there, they're in your new system and you can use DDD and fix them really quickly. Just got a final slide with some closing thoughts. So yeah, number one, if you can avoid doing it, and do. I say that a bit flippantly, but not all systems need to be rewritten entirely. If you can do the tidy first, do some surgery in certain areas, definitely look at that. If it's a third-party system, it's not your core business, maybe there's a third-party system out there that has the advantage of you could just get them to write a migration at that point, because the challenge we've got is we're trying to build something and validate it and keep the lights on and move people across. It always takes longer. It's tempting, I find it's tempting to look at a legacy system and say, what are these people doing? They've made everything so complicated. They could just write it in this clean way. And then as you get further into it, you realise there's a reason why there's that edge case, or it didn't quite fit in the boundary that we also thought it would. It's because the real world's complicated. So probably going to take longer than you think. Having two versions of a data where you're writing to two different, it's one thing writing into a data format you don't really like, but having things written into two copies of a table is just hard. But equally, those hard and fast rules don't last long, so you can have all the principles in the world of I'm only ever going to be the master of the data here and I'm going to write to my tables and sync them back, and then somebody will tap you on the shoulder and say, you do realise that third-party system is creating records every night, and you kind of have to compromise. Key one for me, treat the scaffolding as a key part of your system. It's not going to live forever. Hence point 6, it's really important to take down all those, to come and address what is technical debt as well with the adapters, legacy mimics, take them down, it's really important. But they're absolutely critical, so you can have a perfect new system, in quotes, with loads of tests around it, beautiful clean code. If your adapter has been rushed and it's not syncing all the data back, you're going to have a major incident the moment you put that live. So your adapters, your legacy mimics need just as much testing as the new components you're building. And also I would suggest with high volumes of data, as well, because you haven't got that documentation or knowledge of the existing system. And yeah, the final one, it just makes all the difference if you've got a team that buys into it. If you've got a team that's sort of grumbling and saying, I don't know why we didn't just start again, that is hard work. But if people get it, they buy into it, they can see the progress you're making, then that makes life a lot easier. That's it, thank you. We've got time for questions for Putty.
Yes, question about the point 6 there, getting rid of the scaffolding when you're finished.
Yeah.
How much do you consider we're making this almost more complicated, making it ultimately less complicated?
Yeah.
A stage, as you say, where you're sort of doing both the old and the new system.
Yeah.
Do you sort of build it in a way that you can then take the old system back out, or are you just focused on kind of make everything work in a new sort of abstraction and then kind of refactor that later? Or?
Yeah, no, great question. Yeah, it should be that as you work your way through those hexagons, there's very little business logic left in the old system. So you get to a point where you either kind of live with what's left and you don't need those adapters, or the whole thing just drops out. So that's what you're aiming for, because all code should ultimately come across and comes across as each of those, as you address each of those sort of aggregates. So you're adding more good code over here and existing bad code is dropping down, fortunately. But you're right, the other thing that's increasing is complexity and technical debt around those adapters. So yeah, definitely needs a lot of care. I think the pattern is the Strangler pattern, where you essentially, sounds horrible, but you essentially keep a record of what's referencing those adapters. So at the point where, say with the legacy mimic, if you've come for each of the bits of the system that need that legacy mimic or need the data in that format, then at that point the legacy mimic goes and everything's coming across to your new system. So yeah, you need to have a kind of inventory of that and understand those relationships, and you only kind of figure it out, unfortunately, when you miss things. Even with this sort of safety first approach of putting it back in exactly the same way that it was, you will miss things and find out that there's a process that runs once a month that expects something else.
There's no tests. Would you prescribe like doing the TDD approach to the new thing and not bothering, or would you write the tests, try and get them running on what's there, and then try and run your new code into the test?
Yeah, so for me, I tend to view TDD as much about exploration and getting the design of the software right and understanding the requirements as it is about the tests. I mean, it definitely gives you a useful set of unit tests. That's probably not the number one value it brings for me. So approach I would take, we took, was to have TDD and be really strict on that on the new code. The old code, not so much, partly because it's such a tangled mess. It's hard to get in there and test and get at the parts you need. So yeah, we tend to put more focus on the APIs. So for example, where we had that branch by abstraction with the old and the new implementations, we had we're actually doing quite a lot of that now as well. Side by side, yeah, data comparisons, yeah. Yeah, it's for us, I mean, it depends on the profile of the application, but for us, there's need for having sort of very precise, accurate data, and there's quite a lot of it. So for us, it was around making sure that data stayed consistent, and there may be, data is always important, but there might be slightly different emphasis on a different type of site. Well, I guess the final thing is to go all the way back and see what sort of graph we end up with for the Netherlands versus England. So I'll shut the laptop. Thanks so much, everyone.